So we have skipped over chapters 6 and 7, and we've gone to chapter 8. Oftentimes, this is the last chapter in an algebra textbook, and a lot of times, you don't get to it in class because you run out of time. But we are, in this course, it's designed to actually talk about some parts of chapter 8. We don't cover all of it, but some things. So in 8.1, we're talking about sequences. One of the things we're talking about are sequences. So think of a set of numbers. Let's say I have 1, 3, 5, 7, 9. You could probably see the pattern here, right? Like if you had to say the next number, you could probably figure it out, right? So hopefully you could figure it out. Anyway, the next number would be 11, right? You see how you're just adding 2 to each previous number, right? Or it's odd numbers in this case. But then you know that 13 would be next, and you could keep going with that pattern as much as they want you to, okay? And these 3 dots at the end indicate that pattern continues. They're called ellipses. And I'm trying to think how to spell that. I'm not sure if that's how you spell it. Ellipses. Maybe. Okay. Now, what's important for us to know is that there's a first term, there's a second term, there's a third term, and so on and so forth. Each number is representing a term. How are terms separated? They're separated with commas. Okay, and so we get this list of terms, and the first term, and then the second one, and then the third one, and so on and so forth. Okay, so this is based on what we say A sub n. A representing the term, and n telling you which term it is. Tells you if it's the first term. So A sub 1 in this case is 1. A sub 2 in my case here is 3. And so on and so forth. I could keep doing that, right? Okay, so that's the idea of a sequence. There's some kind of pattern that we're looking for. Okay, we'll talk more about sequences in future sections. Now let's look at this sequence right here. You've got a 1, and then you've got another 1, and you've got a 2, and then a 3, and then a 5. I'll tell you the next number. The next number is 8. And you may have seen this sequence before. It's kind of a famous one. Can you say what the next number would be? Well, it's 13. And then as soon as I tell you what the pattern is, you'll see it. And you'll go, oh, I can do that. I can figure out the next term. But go ahead and stop the video, look at it for a minute, see if you can figure out what the pattern is. And if you can't, I'm going to tell you. All right. Anyway, you came back. Did you think the next term was 21? Okay, and it keeps going. How are we getting these? Well, you take these two numbers and you add them together. 1 plus 1 is 2. And then you take these two numbers, 1 and 2 make 3. And then 2 and 3 make 5. And then 3 and 5 make 8. 5 and 8 make 13. And 8 and 13 made 21. That's where we're getting these numbers. And you could keep going in that pattern and get those. This is called a Fibonacci sequence. And I think that's how you spell Fibonacci. And it turns out a Fibonacci sequence, the numbers are found in nature. Sunflower seeds do a spiral and they count up to be different Fibonacci numbers. And it comes up in other places as well. Okay, now when we talk about this relationship, we're going to go back to what we were talking about over here. If you wanted to write it as a function, you would say f of 1. That would be the first term. Okay, so we're saying what's the first term? It's a sub 1, which is 1 in this case, right? Now if I said f of 5, skip ahead here, okay, then I'd have to count. Here's the first term, second term, third term, fourth term, fifth term. Okay, that's kind of a fluke. It turned out to be 5 again. So a sub 5 was 5. All right, what's the sixth term? Well, it's a sub 6, and that is 8, right? Okay, so that's what we're talking about. A general term, they're going to tell you how to find that general term, but it's represented with a sub n. Now, the sequence is written in set notation. It's the set of all a sub n, okay? So n is an integer, by the way, or a counting number, I should say. It's a counting number or a natural number. Sorry, we say natural numbers usually. Natural numbers and counting numbers are the same. So 1, 2, 3, like that. Okay? That's how you're going to count terms. You're not going to have a sub 1/2 because you're not going to have half a term. You have the first term, the second term, the third term. That's one nice thing about sequences. Okay, so now we understand sequences. So you have a sub 1, comma, a sub 2, comma, a sub 3, and then there's some pattern and that continues, okay? Now, if the 3 dots continue like that, it is an infinite. It keeps going. It's an infinite sequence. And then the last term would be a sub n, right? Okay. But if it's infinite, there's no last term. Okay, sorry about that. If it's finite, then there is a last term. And then it keeps going until you get to like a last term. Maybe there's 10 terms in the sequence. And that's how you'd write it. This would be a finite sequence because it has 10 terms. It has a finite number of them. You could count those up. Okay, so I wanted to talk about that. See if I missed anything. It doesn't have to be the lowercase a. You could use b sub 1 and b sub 2. It could be any lowercase letter. They usually do use the letters from the English alphabet and lowercase ones to represent sequences, but you could have more than one sequence that you're talking about. A lot of times you're going to see it though in terms of a sub n. Okay, so there's a little bit of background about sequences and what we're doing. I'm going to make this a little bigger so hopefully you can see it. So a common question when we're working with sequences is write the first 4 terms. So they don't want you to write 100 of them, just the first 4. And they're going to tell you how to find them. That's the general term. So here it says a sub n equals 3n plus 4. So if I'm trying to find the first term, a sub 1, then n is 1. And so it's 3 times 1 plus 4. Do you see what I'm talking about there? So you're saying this n here is 1, so the n over here is 1. Okay, then we do a little bit of math. 3 times 1 is 3, 3 plus 4 is 7. Okay, that's the first term then. What's a sub 2? Well, it's going to be 3 times 2 now. N changed to 2, and then we're going to add 4. So we do a little math. 3 times 2 is 6. 6 plus 4 is 10. And then we want to find a sub 3. So now n is 3. So we do a little bit of math. 9 plus 4, you can put it on a calculator, is 13. And then finally we want to find a sub 4, which would be 3 times 4 plus 4, which would be what? 12 plus 4? 16. So it asked me for the first 4 terms. You're going to write those with commas in between. And those would be the first 4 terms of that sequence. They tell us the general term. They describe it to us. I didn't mention that before, but that's what the general term is. It tells you how to find terms. Okay? All right, so the next one's a little more complicated. We're going to say a sub 1. Every place there's an n, we're going to put a 1. So negative 1 to the first over 3 to the first minus 1. A lot of 1's going on. Okay, so I'm going to have to do a little calculating. Negative 1 over 3 minus 1, which is what? Negative 1 over 2. Okay, so I get negative 1/2. All right. Oops. I don't know why I put a b there. We've been working with a. A sub 2. Then we're going to have negative 1 squared. So I'm going back to this. They call it a generator. It tells you how to find the term. It generates the term. Generator, something like that. Okay. Negative 1 squared over 3 squared minus 1. So negative 1 squared, that's 1. 3 squared is 9. So I'm getting 1/8. So I just have to do the math, order of operations. Okay, now let's go to a sub 3. Now you can't see the generator, but I can figure it out. It's negative 1 to the third, as I remember what it was, 3 cubed minus 1. So those are the ends that are changing. You see it in two places in the generator here. It's right there and right there. Okay, now I have a subscript of 3. That tells me which term I'm on. I'm on the third term. So for n, I'm putting in 3. Okay, what do I get? I get negative 1 in the numerator. Negative 1 times negative 1 times negative 1 is negative 1. Then I get 27 minus 1, or negative 1 over 26. And I'm supposed to find 4 terms, so I got to do one more. A sub 4 is going to be negative 1 to the 4th power and 3 to the 4th power minus 1. Okay, so negative 1 to the 4th power is positive, and then 3 to the 4th power is 81 minus 1. So I get 1 over 80. Okay, so there's my first 4 terms. Negative 1/2. So you see they're fractions this time. I think it was 1/8, wasn't it? Ah, okay. Negative 1 over 26, and then 1 over 80. Now, why don't we put the ellipses? We're told to just find 4 terms, so we're just finding the first 4 terms. And that's all we're doing here. So we're practicing using a generator and finding terms. What's it based on? It's based on n. What does n represent? It represents which term you're on. The first term, the second term, the third term. Could they ask me to find the 25th term? They could. It might be easier in the first one than the second one, but they could say, hey, what's a sub 25? We didn't ask that in this problem, but maybe we'll see something like that later on.